which maybe you did really well on the test, maybe, I don't know, I have no idea.
No one knows.
But take it and multiply it by 3 or 4 times harder because we're now going from one dimension, we're taking a whole another dimension and putting it in there. Because not going from 1 to 2 doesn't mean it's just 2 times different.
Okay, there's no learning.
What? No, we were on one dimension at one time. We were either on the x-axis or we were on the y-axis. We were not on both axes.
Z-axis. So you're going to say this might be neutral axis?
Yes.
Left side?
Yes. This is where we do vectors. Okay. Alright, here we go. Some of this stuff should be review for you, because I talked about it last chapter. We talked about it in physical science. I know it seems eons ago, right? When you guys were really little ones. And you guys were terrorizing my life as young freshmen. And things have not changed so much.
Didn't you like the Pythagorean class better than the Pythagorean?
Yeah, the class was great.
Our class is just different because it's not two by
All I know is you always made that question every day.
Not till 22, I'm 22.
Sure. I mean, I can't whatever you Yep. Alright. Scalar versus vector. We talked about this last chapter. What is it?
Scalar has only a magnitude, vector has a weight.
Sorry, one person raise your hand. I can't have everybody talking out loud. Okay, Isaiah, go ahead.
What? I was not.
You raise your hand. We'll
Okay.
different than scalar and vector.
Scalar is speed and volume.
Hey?
No.
Okay. Cole, what is
Wait.
it?
Scalar has no direction.
Magnitude.
Magnitude has.
Cole, go ahead.
Scalar is simply a magnitude without a direction, but vector has both direction and magnitude.
Okay, it's really that simple, but it's not that simple, okay? Scalar is just a number.
Volume.
You guys know that a magnitude is just an amount,
Yes.
a number. So when you do things in math, 2 plus 4 equals 6, that 6 is a magnitude. That 2 and that 4 is a magnitude. Okay? I said 2 plus 4.
I know, I thought you said 2 for a second.
Okay, now listen. Vector is a number, but also has a
Direction.
direction. Now, both have units in science. Okay? Example, just from last chapter. Give me some vector examples just from last chapter. Please.
Okay, acceleration, final velocity.
Time.
No, time is definitely not one. There's no.
Wait, direction.
There's no.
Wait a minute.
No,
That's what
also not.
Wait, what?
Scalar, time is a scalar. Why is time a scalar?
Time travel.
Yeah, well, there's no direction of time. It always goes one direction.
Yeah, but isn't there
Time's always positive.
velocity?
Well, you can't go like negative seconds.
Unless we
Not
figure
yet,
it out
yeah.
the flux
Yeah, so
capacitor.
essentially, direction,
yeah.
guys, when we're talking direction in math, we're talking negative or positive,
Yes.
essentially. Right, when I have a negative velocity, that just tells me one of two things. I'm either going south or I'm going east, and this chapter, we're gonna put them both together. And get angles and go southeast and things like that. Okay? Scalar, give me some more scalar.
All of you.
Direction is scalar?
Existence.
In your text are you?
Distance, what else?
No, he didn't. He spelled it. See that.
That's an NA, it's just a language. Okay? Guys, wasting my time, wasting your time. Okay? And they give you, number of pages in the textbook, volume. You don't have a directional volume. That makes sense. You have a directional color. Okay?
You can have an amount of color.
Primary
You can have an amount of color, yes. You can have a like.
I have 513 grams.
I don't think this is really that important. You can usually tell by what you're dealing with that it is a vector or a scalar. I wouldn't be so crazy about whether it's kind of italicized or bold-faced. Okay. Okay. Okay, listen up. Resultant vector. Okay, I want to explain one thing. Vector is just an arrow. Okay, but it's not just an arrow. It is just an arrow, but it's not. Here's how it's not just an arrow. It tells you something. There is a magnitude and a direction that this arrow is telling us. What is the magnitude of the arrow?
The distance of
What did you say?
The distance.
The length of the length of the arrow is the magnitude. So if I had an arrow, assuming I did that correctly, what would be the difference in magnitude of these two arrows? One's double the other, right?
Yeah.
Okay, so could you kind of give a magnitude or a amount based on how short or how long your arrow is? Okay, so if I've got two forces, and one force is that, and the other force is that, I'd say what, about a third? Okay? So, the length of the arrow tells you how much, tells you your magnitude. Let's just say this is 30 newtons, and this is 10 newtons. Okay? Where do we get direction, do you think? The way it's pointing.
Nice.
Okay? So, a vector is represented by an arrow. The length of the arrow tells you the magnitude, whether it's velocity, acceleration, you name it, force. Okay? And the direction it's pointing is the direction that it is going. Okay. Resultant vector. If I have two different displacements, two different velocities, two different forces, you can add them together to get a resultant vector. Okay? And here is an example. We start at what, my home, go to a friend's home, and then to the state capitol building. I don't know. Okay? All right. So let's go a certain magnitude in a certain direction to here, and then turn and change directions, go a certain magnitude, and then here. So this would be my. We're just talking position here. This would be my initial position. This would be my final position. My displacement is what?
Whatever that is.
Or CC.
Oh, no.
There's your displacement. Is the distance and displacement the same in this context?
No.
It's very different. So when we do displacement, we really are using vectors. Now, this is not a one-dimensional motion problem, is it?
No.
Okay? So technically, I've got to orient my problem in a way that will make this easier. And usually you put one of them on the X or Y axis and you deal with the other accordingly.
Is AB the distance?
Yeah.
You added A plus B, yes. Okay? Now, okay, I will tell you how in a second how we get this resultant vector. I just want you to know that the resultant vector is the sum of my vectors. Could I have 12 vectors and get the sum of all those 12 vectors and figure out, for example, let's say I started here, I went here, and then 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 I went here. What's my displacement? Right there. Okay? So, displacement is, if I were to start from my initial position and go in a straight line to my final position, that would be my displacement. Okay? And that's what we're going to be dealing with. Okay, so you can have an outrageous amount of vectors. Okay. So how do we add vectors? There is a correct and a not correct way to add vectors. All right. This is important. Let's say I've got forces. I've got a toy right in the middle, and I got one kid pulling this way, one kid pulling this way. just by sheer common sense, what's that toy going to do?
Wait, right.
One's pulling this way, this is a toy, and they strap the string to it, or something, I don't know. Okay, let's say there's a boy here and a boy here, and they strap the string to a toy, and they both pulled. What's that?
Diagonal.
Yeah.
We'll do that, wouldn't it?
Yeah, sure.
Okay? Alright. Well, we can add these vectors to get us that resultant vector, actually. And here's how we do it. It says, vectors can be moved parallel to themselves. So I could take this vector arrow and I could go this way or I could go this way. I cannot go spin it. For example, if I move it this way or move it further this way, is that, assuming I kept the arrow the same length? It's kind of hard to do that.
And it's an arrow on this again.
Okay, let's assume that I can actually write a perfect arrow every time. Is the magnitude and direction of all three of these the same? Yes. If you move them parallel to each other, doesn't affect the magnitude, doesn't affect the direction. So you can move them parallel. You cannot rotate them. So I cannot take this and go like that, because that changes the what?
The slope.
Well, yes, but the direction, right? Okay? Now, here is something you can do. What if you want to subtract a vector? What do you think that would look like? It'd be the same magnitude, but opposite direction. So I could take this, and I could subtract it like that. Same magnitude, opposite direction.
Wouldn't it also be on the other side of the dot?
Yes, I'll get to that in a second. Okay? Now, here's another important thing. Okay? When you are connecting or when you're adding vectors, because we're typically going to add vectors, not subtract them. Okay? We'll typically just add. Okay? You have to have the tail go to the tip. And here's what I mean. Okay? Tail is going to be this portion, tip is going to be this portion. Does that make sense? Okay? So I have to have the tail of one vector connected to the tip of the other. I can do this two ways. I can keep that one the way it is, and I can move this one parallel up to here. Everyone see what I just did? Tail, tip, connected. Cannot be any other way. Now, could I have taken this one and moved it over here?
Yeah.
Yes. Let me show you. I'm going to take this and I'm going to move it over like this. The resultant vector is going to be the difference between the beginning and the ending point.
The line.
Are they the exact same resultant vector? Yes, we're going to do a lot of Pythagorean in this chapter. A lot of SOHCAHTOA in this chapter.
We use the same formula.
SOHCAHTOA?
Yes.
SOHCAHTOA.
Okay. Shh. Just notice. Are these resultant vectors the same?
Yeah.
Now this one we just guessed what it would, from common sense, if I have two forces pulling in these directions, what would happen. Okay? But it didn't matter whether I move this one parallel or whether I move this one parallel. No, as long as I have tip to tail, or vice versa, we should be fine. You cannot have tail to tail. That's not right. You cannot have tip to tip. It's not so funny. I don't know what's so funny.
Make them repent.
Repent! Get on your hands.
Sorry. Oh my God.
It was like 5 straight minutes of sentences.
That does not work biologically. Okay. Alright.
Self-control. So much self-control.
The resultant vector. Okay, so the resultant vector would be the dashed line that I was showing you. It's the sum of your vectors. Make sense? Follow. Any questions so far? Alright. Ah, fine. Yeah, when we put numbers on, I'll explain. Okay. These are usually really, really bad, and I kind of watch them because they're funny. Because they're really bad? Yes. Sometimes they're good, not always. So,
Vectors can be added graphically by drawing or positioning the vectors one at a time with the tail of each new vector connected to the tip of the preceding vector. Note that in order to add vectors, they must have the same units and describe similar quantities. The result of adding two vectors is called the resultant. The resultant vector extends from the tail of the first vector to the tip of the final vector. The order the vectors are added in makes no difference. Let's start with the same set of vectors again and put them together in a different order.
It's not the same.
You get the same resultant if you add the vectors in any sequence.
so you're saying 2 plus 4 plus 2 is 8, 4 plus 2 plus 2 is still 8? Yeah, so here's the
What's the
thing.
big difference?
As long as you have them tip to tail, you should be fine. Doesn't matter what order you do them, how you do it, as long as you have them tip to tail. Now, this would be like the displacement. You're changing x. If I went the whole thing, it would be my what? Distance. Okay? Okay, this is kind of what this is saying. It can be added in any order if you have to subtract. Like, let's say I've got this, and this is A, this is B, and they want you to take A minus B and write what it would look like. Okay, it has to be tail to tip. Okay, if I'm doing negative B, it'd be the opposite of B. What is that?
Negative, whatever the.
Flipped. So it's the same magnitude, but flipped, and then I'm going to have to do what?
Change the sign.
Yeah, what happened to tip to tail?
I haven't done it yet.
It's a tail to tail right there.
Okay, and then I'm going to move in parallel, either up here or move this over here, doesn't matter. So this would come up here, and that would be subtracting B from A.
Okay.
Adding B from A would be this.
Oh, it's just the pause button.
Yeah, so because the vector was here, I flipped it and then tail to tip.
Notice how
That makes
one's
sense.
positive, so the other.
Yes. Yes. Okay?
So if it says add B, you just move that.
What's that?
If it was A
Holy
plus
give
B,
me
you
life.
would just move it up.
Yeah. Or you could have moved either one, doesn't matter.
Plus.
Like, I don't remember which one was A, which one was
So
B.
just funny sounding words.
I don't know, it doesn't really matter. That was B. If it was A
Which is
plus
funny
B,
sounding,
Then you just move it up.
you can either move this up or you can move A over, it doesn't matter.
Okay,
As long as you move them parallel
Okay.
and tail to tip. Okay? So let's let me just show you what this looks like from a mathematical standpoint. If I want to know the resultant vector, like let's say it was I went from my house to someone else's house and then I went to the school. Okay, and I wanted to know the displacement. I would take and do tip to tail.
Yeah.
There's my resultant. Let's say it was 3 meters to get to my house, and then 3 meters to get to some other person's house, and then 4 meters to get to the school.
5 meters for each school.
What is your displacement?
5 meters.
Because of the.
What?
Second theorem.
Oh,
Yeah.
you just wrote that, I multiplied that. Oh.
Okay. Now, I mean, it's gonna get more complicated than that because then we got to figure out what this angle is. We got to know what that angle is. We'll have to figure out what the angle is. The inverse tangent.
45.
It's a.
Okay, this one's a 45. But what if it's this, this, this? I got an angle here, I got an angle here, and I got an angle here. And my resultant vector is an angle here.
That was.
Yeah, 530. We'll go all the way to your x.
This doesn't like you go get out if you add the three small hands. Oh, there, no,
Okay. Okay, multiplying or dividing vectors by scalars is possible. So I could take like a vector that's like 20 newtons is my magnitude, and I could take and multiply by a scalar, or aka I could double it. Is just 2 a scalar number? Doesn't have a direction, just 2?
Yes.
Okay?
It's odd.
It doesn't matter, because remember, scalars don't have a direction, so. Okay? So you can double, triple, you can do things to vectors as long as they're scalar. You can multiply vectors, but then you've got to keep their units in order. Okay? But if you're going to add vectors, they have to be the same unit. Like I cannot take like 14 inches and then a vector that's 20 centimeters and add them.
Tell me the rules that have to apply everywhere we use math.
Yes. Okay. Let me see, what's next? Fine.
It's a phenomenal test.
The UI interface.
Oh yeah, here we go. I already explained this, but good to hear from somebody else who's more intelligent.
Just as vectors can be added, it is also possible to subtract them. We remember that subtracting a number is the same as adding its opposite. For example, 10 minus 5 is the same as 10 plus negative 5.
Whoa.
The same holds true with vectors. To subtract the vector d2 from the vector
Add its
d1,
opposite.
we simply add a negative d2 to our original d1. The negative of a vector is defined as a vector with the same magnitude as the original vector, but opposite in direction.
Okay, so I don't know if you made that connection or not, but
Wait, how did they make it not? What did you make it on the opposite direction?
they flipped it.
I didn't see it flip through.
It was this
It looks like,
direction.
oh, why is it D? Why is it negative though? Because it looks like
Oh.
it's going up.
Oh, they're saying subtracting it, the opposite. So,
Oh,
Yeah.
okay.
okay?
Got you.
Did they flip the same time moved up?
Right before, I think. Okay. Alright.
Those look like links.
Can you shut off the lights? Oh, you got his fingers.
And God said, screw you.
God said you're demoted to bronze 5.
You lost 5 minutes.
Alright.
Yes.
Yes.
Oh.
Is that the Lego movie?
Turn it up.
I have it all the way up.
It's all the way up and you have. Why are these things so confused?
Turn up. The bar, the gray bar on the actual speakers. On the actual speakers. Oh my word.
I have it all the way up.
Check your windows on.
your
Yeah,
computer.
check the
Get that up there.
Starting over.
I'm applying for a new film loan. Go by the name of Vector. It's a mathematical term. Quantity represented by an arrow with both direction and magnitude. Vector! That's me, because I'm committing crimes with both direction and magnitude. Oh yeah!
Maybe I should have shut that video off.
Piranha Oh yes! Fires live piranhas. Never seen one before. Now you have my attention. You want a demonstration? Oh, ow!
I forgot how much better the first movie was than 10.
Oh yeah, you're right, dude.
Alright, so let me explain something for homework here. Alright, we're gonna get done a little bit early. That's not normal.
What?
Not right.
Early? But we were gonna waste time.
Yeah, we waste more time. Let's
Yeah.
We wouldn't have been early had we had to go over the test and I had to deal with all the bazillion questions.
Well, you and your lazy.
I want this point back, and I want this point back, and I want this point back. This wasn't fair.
I
It
need
said,
you to throw
it
it
said
all the
plus plus when it should have just put this plus sign.
Yes, exactly.
Wait, you're docking for that?
He's like,
Because I put west instead of negative.
Dude, it's the same thing.
I know, but he just
Remember,
said.
you knew this is nowhere.
Turn your book. Turn your book to whatever your homework page is.
83.
Is that the one that says which of the following quantities are Okay, 2, 3, and 4. We're actually not going to. What they wanted you to do is they wanted you to get a protractor out and use a ruler. We're not going to do that.
Yes.
Okay? So here's what I want you to do for number 2. I want you to draw a picture of what it's saying. So let's say I've got one where it says, I travel east at 20 meters. Okay? East is straight east, right? So there's my, if I have my XY axis here, I would say 20 meters. And then it says I turned at an angle of 35 degrees north. Turned at an angle of 35 degrees north, that would be, and I went 10 meters. Now, are you going to get a perfect,
That is not 35.
oh shit, that's a little bit more than 35, but not much. What is the resultant? So I want you to do
Yeah, but.
that. And I'm not asking you to solve anything. I would say some amount of meters and some unknown angle. Okay, all I want you to do is draw a picture of it. We're not actually solving yet.
Okay.
That's not the answer to any of them. I just made it up.
Wait, so I don't know.
Okay?
But you just want to draw a picture.
Yeah, all I want you to do is draw a picture and I want you to label everything.
For all of them? Or just?
There's just 3 of them that you're doing this.
Just 2?
2, 3, and 4 are the only ones that are problems, right?
2, 3, and 4.
Right? But I want you to show them tip to tail, like you should. I want you to show the angles if you know them. And I want you to show with a dotted arrow what your displacement vector looks like. I don't want numbers, I just want you to do the picture. I'll do numbers tomorrow.
Oh, there's 5 parts to that.
Yeah, there is. That's called a.
That is.
That's called a Roy.